For years, the rule in AI was pretty simple. Bigger is better. If you wanted a smarter model, you made it more massive. But that whole brute force approach, it's really hit a wall. So let's dive into this really elegant solution that's changing the game. It's called Mixture of Experts. And that idea, it's absolutely the key. You don't need every expert for every problem, right? You just need the right expert. And believe it or not, this simple revolutionary insight is exactly how some of the world's most powerful and, more importantly, efficient AI models like Mixtral and DeepSeek actually work. Okay, so to really appreciate why Mixture of Experts is such a game changer, we kind of have to go back and look at the problem it was designed to solve. And that brings us to the era of the dense model. Now, don't get me wrong, these things were powerful for sure, but they were also becoming incredibly, wildly inefficient. So, what exactly is a dense model? Well, I want you to imagine a factory where every single machine is running at full power, 24/7, no matter what it is you're trying to build. It doesn't matter if it's a tiny screw or a whole car, everything is on. That's a dense model. Every single part of its brain is fired up for every single task, big or small. And here's how that works in practice. A single word, or what we call a token, comes in, it goes through the first layer, and it's processed by all the neurons. Then it goes to the next layer, and it's processed by all the neurons there too. This happens over and over. Nothing gets skipped. It's effective, yeah, but it's like using a giant computational sledgehammer for every single task. And this is the real world's cost of that brute force approach. We're talking about potentially $100 million to train a single top-of-the-line dense model. I mean, that is just a massive, massive barrier to entry. It puts this kind of technology completely out of reach for almost everyone. Clearly, the industry needed a much smarter way forward. And that smarter way? It's called Mixture of Experts, or MO for short. And what's kind of funny is that it's not even a new idea. It actually dates all the way back to 1991. It just got dusted off and revived to solve this very modern crisis of scale and cost. So let's see how this elegant approach works. Here's the fundamental shift in thinking. Instead of building one giant do-it-all brain, Mo creates a whole team of smaller, specialized experts. The core question the model asks is, hey, what if I didn't have to use all of my knowledge all the time? What if I could just pick and choose the specific bits I need for this one problem? And you can see the difference right here. The token comes in just like before. But then, and this is the magic part, this new component called a router steps in. It takes a look at the token and acts like a traffic cop, sending it to only a few of the available experts, just the ones best suited for that specific job. All the other experts, they just sit this one out, saving a huge amount of computational energy. So this router, it's really the unsung hero of the whole system. Let's go back to our hospital analogy. The router is the triage nurse. It's the one who sees you walk in, assesses the problem, and says, you know what, you need to see the dermatologist, or this one's for the cardiologist. Its entire job is to be the smart dispatcher. But this brings up a really critical problem, right? What happens if that router starts playing favorites? And this was a huge issue in early MOI models. They called it routing collapse. The router would just get lazy, I guess, and start sending almost every single token to just one or two of its favorite experts. And that, of course, completely defeats the purpose of having a whole team. So the solution to that is a pretty clever technique called load balancing. You can think of it as a set of rules that basically forces the router to spread the work around. It makes sure that all the experts get a chance to learn and contribute, which is super important. This keeps the entire team sharp and, crucially, prevents any one expert from becoming a bottleneck. Okay, so this isn't just some cool academic theory. Far from it. Mo is the proven, battle-tested architecture behind some of the most impressive AI models out there right now. It's completely reshaping the entire competitive landscape as we speak. I mean, just take a look at this timeline. It's wild. In just a couple of years, we've gone from Mixtral making MOE popular in the open source world to models like DeepSeek V3 achieving just unbelievable scale and efficiency. The pace of adoption has been absolutely staggering. And this right here, this is the visual that says it all. Check it out. DeepSeek V3 has a total knowledge base of 671 billion parameters. I mean, that is just enormous. But, and here's the kicker, for any single word it has to process, it only activates 37 billion of them. It literally has the wisdom of a giant, but operates with the speed and cost of a much, much smaller model. It's the best of both worlds. And you can see this isn't a one-off. It's the same pattern across the board. Look at Mixtral, Grok 1, DeepSeek. They all have this huge gap between their total size, all the knowledge they hold, and their active, in-the-moment compute cost. That, right there, is the core advantage of Mixture of Experts. And the designs just keep getting smarter and smarter. For example, DeepSeek V3 introduced this really clever idea called a shared expert. It's basically one generalist that's always active no matter what. It provides a baseline of common knowledge for every single token, and it works right alongside the specialist that the router picks. It's exactly like having both a family doctor and a whole team of specialized surgeons in your hospital. So, why does any of this matter to you? I mean, it's cool architecture, but what's the big deal? Well, the big deal is that this isn't just a technical change. It's a fundamental economic one. This shift in how we build these models completely changes who can afford to build and use top-tier AI. Now, to be fair, it's not a complete free lunch. Maui does have its trade-offs. The big one is that while it's much cheaper to run a query, you still need enough expensive memory, what's called VRAM, to hold all of those expert models, even the ones that are just sitting idle. Plus, fine-tuning them can definitely be a bit trickier than with a straightforward, dense model. But let's bring this whole story full circle. Remember that crazy $100 million figure we saw for a dense model? Well, get this. DeepSeek V3, a model that truly competes with the best of the best, was reportedly trained for just $5.6 million. That is a staggering, mind-blowing 95% reduction in cost. So what does all this boil down to? It means Mixture of Experts is making powerful AI more democratic. It's lowering that massive barrier to entry, which allows startups, university researchers, and smaller teams to actually compete with the tech giants. And for the rest of us, it means we're going to get faster, cheaper, and way more innovative AI applications. Which kind of leaves us with this final big thought to chew on. We are actively moving from a world where only a handful of trillion-dollar companies could afford to build cutting-edge AI to a new world where that cost is just falling off a cliff. So the really interesting question is no longer just about what AI can do, it's about this. When AI gets 95% cheaper, who gets to build a future?